Hi, welcome back. Again, my name is Orlando, and in this video I'm gonna briefly talk a little bit about some of the different data types available in R. So to more easily go through all the different things I wanted to talk about, I created this script, which hopefully you'll be able to access if you're interested in following along. Uh, if not, it's not really too much of too big of a deal. You can just easily replicate what I'm doing. Okay, so there's several different types of data that you can create in R. So by data, I mean here, data types, I mean objects that you can assign as a you can save as a portion of memory in your computer. So for instance, I guess the most basic type of data type that there is are variables, which can be numeric, logical, or integers. I mean, there's a few others, but I guess these are the main ones. So I guess the most important one type of variable is numerics, a numeric variable, which essentially works like this. If you want to assign a specific number to a piece of memory in your computer, so you want to create a variable which stores specific number, then the procedure goes like this. You first decide on the name of that variable, then this operator here is the operator that forces this variable to contain to be named after whatever value is holding, and then finally here you indicate what is the number, the quantity that you want the variable to store. So I'll go ahead and run this, and after I run it, this variable x, which now you can see here in the environment, now stores the value 3.4. So if I put on the command line x and hit return, I'll get the value 3.4. I can now manipulate it. Let's say x plus 5, which is 3.4 plus 5, which is 8.4. I can also square it, do everything that I could do previously with a regular number. I can do now in terms of x, which is now a variable that stores, in this case, 3.4. I can also reassign its value. Let's say now I wanted to store the value 10. I can do that. And you can see it's changed over here. So I can easily do that. Okay. So here y is just another example. And now you have here two variables stored in your environment. So these are numeric variables, which are very useful. There's also logical variables, or also called Boolean variables, which can only store two types of values, true or false. So for instance, here I have the value true, one false, and another one true. And I will briefly go through some of the operations you can do with logical variables. You can compute the operator AND. So let's see, P and R, which is true and true. If I run it, I'll get true. So true and true is true. P and Q, which is true and false, is false. So if I'll run it, I get false. And I can also do multiple ANDs. So if I do P and Q and R, which is true and false and true, is also obviously false. So I have here. Okay. By the way, also you can see here in the environment the variables P, Q, and R now over here. Now the logical OR corresponds to this operator, to vertical bars. So P and Q is true and false, which is true. And I can do several OR operators in a row, so which is true and false. I'm sorry, true or false or true, which is true as well. The not operator is given by this exclamation point. So if I do not P, which is not true, i.e. false, I'll get false. If I do not Q, which is not false, that is true. And if I do, for instance, P and not Q, which is P and true, which is true as well, Oh, by the way, if you try to do operations, algebraic operations on a logical variable, it will actually be converted to a binary variable. So a true will be converted to 1, and a false will be converted to 0. So if I try to do, let's say, p plus 5, I'll get 6. So p was true, so it's not converted to 1. If I do q times 3, I'll get 0. So 0 times 3 is 0. Okay. Now you have also integers, which basically you can always use a numeric instead of an integer. Integers are basically when you're sure that a specific variable, numeric variable, will only hold integer values, and you can tell the computer that so that it can store that number using less space. So this is probably not very relevant for you, but in some situations when you may want to optimize your code, this is good to know. By the way, so if I create an integer variable here, let's say n equals to 5, then because I created it as specifically as an integer, then if I inquire the class, let's see, of x, I'll get numeric, so x is over here 3.4. If I inquire the class of, so the data type of n, I'll get integer. And if you create, let's say, m to be, let's say again 5, but if I don't specify that I want it to be stored as an integer, then if I inquire its class, its data type, it will tell me numeric. So it's actually, in a sense, wasting memory in your computer, which is fine for most cases. So unless you really want to optimize your code, then you may want to do this. Okay. Now you also have characters and strings. So very briefly, you can create variables that store. So a string is really just a sequence of characters. Characters are just typically your A, B, C, and some other types of special characters. So for instance, you can create a single characters. The variable C now stores the value, the string or the character A. You can create a longer string, so a sequence of characters. So S now stores the value. Where is it? It's not appearing over here for some reason. Oh, it's here. This is a string. And you can do things like concatenate different strings or characters. So if I concatenate C and S, I'll get this. A, this is a string, which will separate the first string with by the second one with a space, but I can also do it without a separation. I can also try to figure out a substring from a string. So in this case, from the string S, let's see, I want the substring from the 3rd to the 11th character. I can do that, and I'll get this is a substring. So you probably are not really going to use too much of this. Now, this is probably the most important type of variable, maybe after or even more than the regular variables, which are vectors. So vectors are really just sequences, basically, of either numbers or other more basic types of data types. So typically, when we talk about vectors, we're talking about numeric vectors, which is, again, just a sequence of numeric variables. So I can create here the vector with which stores the values 3.4 and then 5 and 8, 2.3 and 6.1 in order by using this command C. And now I have the value, this vector stored over here, which you can see over here. Let's see, I'm going to create just another one just so you guys can see. And these are kind of two ways to create specific types of vectors. So if you run this to 8, you'll get, so in general if you do A, B, you'll get a sequence that goes from A plus, so it goes A equals 1, etc., all the way until B. This is what it does. Okay? And you can also more specifically or more detailed, in a more detailed manner, create a sequence. Let's say here the sequence from 1 to 16, jumping every 3 numbers. So if I do this, I'll get the sequence 1, 4, 7, etc. So it's jumping, it's making jumps every 3 numbers. Okay. I can create vectors of integers or of logical values. So let's say this one P. So it's now stored the vector of values true, true, false, true. So if I do here, I'll get this vector. And now some basic algebraic operations we can do. So basically everything that you could expect to do, you can easily do. So you can multiply by a scalar, you can add vectors. Typically you expect them to be of the same size, you can subtract them. But if they're not of the same size, you can still do the operation, although it is not really recommended unless you really know what you're doing. And what it will do is it will take the smaller of the two vectors and it will sort of loop it around the larger one. If you have, let's say, 3 or let's say more than 2 vectors and they're all of different sizes, then it's even a trickier situation. So this is not really recommended. Actually, when you try to run this, because U and V have different sizes, R will actually give you a warning message, because again, this is really not a very good idea to do usually. Okay? So some other types of operations you can do. I'm going to clear the command line. You can, so I'm going to just print U to more easily see what I'm doing. I can figure out the maximum in U, which is 8 in this case. I can figure out the smallest value in U, its mean, so it's adding everything and dividing by the number of elements. I can compute its standard deviation. I can also compute the variance. I can sum everything. I can figure out the length of a vector, which is 5 in this case. These are some operations that are computed element-wise. So if I do, let's say, U exponential 3, so U cube, it will compute the cube of each of its values individually. So the first value, which is 3.4 to the cube, is this, and then the other ones. I can also do exponential, log of sine, and these are all done element-wise. Now to access and reassign values, it's very easy. I'm going to clear this up and print again U. So if I want to access a specific value, I just use this type of parentheses. So this is the 4th entry. If I want to reassign a value, I just use kind of the same command, but now use the regular assign operator, and I will reassign the value. And you can now print U to check if it worked, and it did. As you can see, its 5th value, it went from 6.1 to -20, which is what I wanted. I can also create, although you have to be a little bit careful when you do this, you can also assign a value from an entry that does not exist. So if you do this, it will create that value, it will assign the value you wanted, but the values, the entries in between, will now have will be assigned the value NA, which is not available. Okay, so you have to be careful then with the computations you do based on this. So, for instance, now this value U, this vector U, since it has these non-available numbers, if I try to sum everything, it will actually give me the result non-available, because it doesn't know how to compute the sum with these no numbers that are over here. Okay, you can also access. Again, I'm going to print U. You can access several entries at the same time. So if you have a vector and you try to access a subvector indexed by another vector here, you can do that. So here I'm interested in the 1st and 4th value at the same time. So it's a subvector. I can also do it with numeric, with logical vectors. So if I create this logical vector, true, false, false, true, false, and I compute U of P, it will give me the 1st and 4th values, which are the same as before, as I wanted over here actually. True, false, false. So what's going on? Didn't I update P? True, false, false. Yeah. I am not quite sure why it's giving me these last two. Oh, I know. Yeah, because of the length of. Okay, so I made a mistake here. So, okay, this is kind of funny. Since P doesn't have the same length as U, then it doesn't really know how to do this. What I wanted to do is it's actually looping P around, so it's doing first and fourth, and then later on, so 6th and 9th value, which are not available and non-available. So hopefully, usually you'll have this vector to be the same length as the vector you're trying to figure out a subvector from. So be careful about that. This is just kind of a remark. If you try to access a non-integer value, it will round it down actually to to its floor value. If you do minus an entry, it will disregard the entry indexed by the number you have, and you can also disregard several entries at the same time. So here I can disregard the first and the third. So if I do this, I'll get number 3. Oops, actually no, never mind. I'll get this subvector, which consists of everything over here except the first and the third. So it will ignore this one and this one, and you can see over here it's working fine. Okay. Well, and you can also reassign multiple values at the same time, much like before. So you just have to use this type of operators. Now, data frames, you'll probably use these. So let's say I'm going to create 2 vectors of the same length, and another vector of strings, and a vector of logical values. So a data frame, which I'm going to create here using this command, data.frame, UVW. I'm going to print it here so you can see. A data frame is really just a table, so it's a matrix basically, with the added flexibility in that each column does not necessarily, so you can have multiple data types inside a data frame as long as each column is consisting only of one type of one data type. So here the first and the second column are numerics, and the third column is a column of strings. So if I try to create a matrix using this, it will fail because matrices are another data type, which the expectation is that the data types inside the columns and rows are all of the same. I forget if they all have to be numeric or they can be other things, but they for sure have to be all of the same type when you're dealing with a matrix. But this is not the case when you're dealing with data frames. So they're very flexible because you can have values that are numeric, and you can have what we call factors and other things. Okay, you can also add columns from an existing data frame by using this command, cbind or column bind. So I'm going to add the column P, and as you can see, it added this column. You can change or assign names to the rows and columns. So let's say here I want the rows of this data frame to be called row 1, ABC 2018, and each columns AAA, XYZ, and as you can see over here. So I'll do this. I'll run and print the data frame again. As you can see, now the rows and the columns have the names that I wanted to assign. So sometimes that's very useful to more easily understand what's going on. Also, by the way, here in our studio, you can use this command view with a capital V, view, and now you write down the name of your data frame, hit return, and you'll have over here your data frame in a way that you can access easily in the future instead of having everything on the command line. So also you have more space to have more columns, so sometimes that's useful. Okay, let's see more. You can access elements from a data frame easily. So let's say I wanted an entry from a specific row in the specific column. So let's say here the second row is the third column. So I just use these rectangular parentheses, and I'll get number 1, 2, 3. Actually, it's a string. Let's see now the first row and fourth column. Oops, I'm sorry, did something wrong. I'll get the value true. So actually, let me print the data frame. So the first row, fourth column is true, as you can see. I can also access an entire row. So let's see the second row. I'll just use 2, nothing, and it will know I want the entire row. As you can see, it works. This is the second row. I can also access a column. So let's say the fourth column, and it works. So this is the fourth column. Now it's sort of printed horizontally, but that's just because it's now transformed into a vector, but it's still the same values in the same order. I can also access columns by name. So for instance, this column has the name, I assigned the name XYZ, so I can access it through its name by using this $sign command. So df of XYZ, and it will tell me that column with the name XYZ. I can do kind of the same with rows, but the notation is a little bit different, so I have to use the rectangular parentheses as well, but I don't have to remember the number of the rows. I can just use its name. Sometimes that's more useful than recalling specific numbers. So I hit return, it works. And yeah, so again, this is the same data frame. Okay. And by the way, I think I mentioned it, but just in case, when you access a row or a column that's transformed into a vector, unless, well, actually a row, if they're of different types, it's not really a vector. So usually most of the time you just access columns, although sometimes it's useful to access rows, but you have to be careful about the types of the data types inside a row, so you don't get things like numbers and strings in the same vector, which is not actually a vector, but okay. Oh, also, you can reassign values easily to rows and columns. So let's say here I want the row XYZ to now have this value, so I can easily do that. Oops. As you can see, now it has the values 1000, 1000, and 0. Now, also, there are many other different data types available, but I don't think it's really worth it for me to go through all of them. So let me just briefly mention there are matrices, which I already talked about. They are very similar to data frames, except they're less flexible, so they need to be all of the same types, data types, the entries. And they may need to be numeric or not, I don't quite remember. Actually, we can look it up here and help. Yeah, they don't have to be necessarily, you can even find, yeah, they don't have to be necessarily of the same type. I'm sorry, of numeric, but they do have to be of the same type. Now with matrices, you do all your regular matrix operations. So matrix product, transpose, all of that you can easily do with matrices, although R is not usually used for that purpose, but you can do that. Arrays, I'm not going to go through. So there are arrays, lists. You can look up what each of these are for in the help menu or online. Tables that this may or not be useful for you, so you can create contingency tables, which basically count how many instances occur in a specific vector. Functions are kind of a special type of data type, which I will go in more detail later. And I guess this one TS, which are time series, is another data type which we're going to use quite a lot. So I'll go through that in the future, not now. Okay? Well, thank you.